Hello everyone, with a new lecture with SPE Mngmnt University chapter. Okay, we're here with another and a new lecture with Professor Ahmed Hussain with a topic of petroleum engineering, secondary recovery, water injection, and floating. I would noticing that we are as a student chapter for SPE memberships. We sincerely give our thankful for accepting our invitation for Dr. Hussain and the offering from Dr. Sadiq from Electricity Department in Mngmnt University to give us the Zoom to managing our lectures in. I would take a few moments to introducing our speaker for today's lecture. Dr. Ahmed is a professor of petroleum engineering. He's highly qualified and well-experienced petroleum engineer in production and reservoir engineering, currently working as a freelance professor and a visitor for some British universities. Dr. Ahmed was a senior lecturer and director for Petroleum Technology Programmes at University of Teesside, Middlesbrough, UK. Dr. Ahmed is a visiting professor at Heriot-Watt University, Dubai campus. Dr. Ahmed was professor of petroleum engineering at the American University-Sharjah, advisor for SPE-AUS chapter, and chair the Petroleum Engineering Minor Committee. Dr. Hussain Ahmed has more than 36 years of experiences in oil and gas industry in Europe and MENA. He also has experience in teaching, training, and research. Dr. Hussain has authored several technical papers and scientific articles in recognition for his high quality work. He was awarded on few occasions, such as 1998 One Halton College Honor Award. 2000, he received Best Doctor Award NW England DFE. 2003, received the Medal for Excellence and City and Gold List Doctor Award. In 2006, got the M.B.E. Award by Her Majesty the Queen on the New Year Honours List for services to education and training in the UK and overseas. I would nicely thank you for joining us today and for Dr. Hussain, of course, to accept our offer and joining us today with a new lecture for University of Mngmnt SPE chapter. The mic is yours. You could start your lecture. Thank you.
Thank you, Yamama, for the introduction, and I thank also the SPE chapter and the Mngmnt University for this opportunity. It's a free webinar. Our aim is to share our knowledge and our experience with the young generation, especially petroleum engineers or people who work in the oil and gas industry. As you see from the slide in front of you, the title will be about water injection and flooding, which I will cover a few topics on that. My lecture will be almost 90 minutes, 1.5 hours. 1 hour I talk, and the half an hour for you to question me at the end of the session. Great. So if you can take notes or any question you want to ask, take a note and ask me later, or if not, you can write in the chat box the question you want, whether in Arabic or English. So I will start talking about this topic, about the water injection, which is part of secondary recovery. Very important stage in the life of the oil fields to maintain the pressure and to maintain the productivity of these reservoirs. So I'll explain that in a minute and in details. Currently, I am also working as a director with a company based in Liverpool in the UK. And here is Liverpool, the northwest of England. And also we do a training and education for petroleum and oil companies. In my agenda, I will cover the following topics, such as the difference between water injection and water flooding. What the difference between them? What do they mean? And the question is, why do we need water injection? Why? And if we know why, next question said, when can we do it? At what stage of the life of the field I start? So when and why is important. Then what's the economy behind it? Is it going to be expensive, costing money? Is it going to be more than the cost of oil itself? That's also going to be answered. Then what are the major problems I could face in water injection or floodings? Whether these problems could be surface problem or could be subsurface problem. What are they? I'm going to talk about some of them. I put today about 10 problems. I'm going to talk about them. Then we come to a conclusion and recommendations for any future projects on water injection. Hopefully I finish within 1 hour. Then I leave the stage for you to keep asking me, as I say, the question and answer. So that's the plan or the agenda for this a master class. I call it master class, a free webinar. Water injection, or generally with secondary recovery. Secondary recovery is a stage important in the life of the oil fields. So first, the blue curve, that's primary, where you are depending on the reservoir pressure to produce the oil. But you agree with me, with time, if you keep producing, the pressure of the reservoir will be depleted, will be small. So I need to boost it up. I need to enhance it. So I have something called secondary recovery, the red area. Under secondary recovery, you have two titles, one called gas injection and the other one called water injection. So gas injection and water injection, both of them come under the title of secondary recovery. Today, I talk about water injection, and maybe, inshallah, when I get opportunity, I talk to you about gas injection, maybe in other sessions. Then after the secondary recovery, the question will ask, water injection being done? I cannot do any more. What shall I do? Then we come to the green area, and we say we'll do something called tertiary recovery. Tertiary recovery. المرحلة الثالثة, third stage. And that could be something else, not water. Could be water with chemicals inside it. Could be polymer. Could be surfactant. Could be water mixed with other additives to make it more recovery for the oil. So these are come under the title of enhanced oil recovery. The red one and the green one. The blue one is a primary, nature, from Allah. Nature give us a pressure, and the pressure push the oil to the surface. Under the tertiary, sometimes you have something called IOR. And we have EOR and we have IOR, and that stands for increasing oil recovery or improving oil recovery. This could be an ESP, electrical submersible pump, could be a gas lift, could be something else. So all these together come under the tertiary recovery in this case. So my lecture today is about the red area. And in that red area, we have two types of recovery, either water injection or gas injection. In my lecture today, I talk about gas injection, and sometimes we call it gas flooding. So keep that in mind. These are useful information for you. So when do we do it? Usually, we do it in order to maintain the pressure we have lost from the reservoir. And also we do it because we want to get more oil production. So that oil production could become because the water will help me in mobilizing the residual oil. I got oil. There's oil in the rocks, but the oil is stick to the rocks, cannot move. So can I wash it? Can I displace it? The answer is yes. How do you do that? You do water injection. So that's example. Or there is also an oil which is not swept very well. The oil is a bit sticky. We call sometimes the oil phase reservoir or oil wettability reservoir, hydrocarbon wettability reservoir. A reservoir which like and love to keep the oil in it. I need to take the oil out of it. So water injection can help as well. So these are the reason. Pressure being dropped. I have not much pressure. I have no much production. I have oil is not mobilized. I need to move it. I have oil which is stick to the rocks. I need to wash it, to take it out. So remember, these are the reasons. Pressure low. I have oil left behind. The oil is immobile. I want to make it mobile. The oil is sticky. I need to sweep it out. Sweep بالعربي يكنس. Last things, I have not forget the economics. Always in any petroleum engineering activities, especially if you are an engineer, you have to have a basic knowledge about economics. How much it costs me in terms of capital cost and in terms of OPEX, operational expenditure. So you need to know basic economics, not very big, but important. So we have these three titles, as I said, primary, secondary, tertiary, and I would explain them. And secondary, already I mentioned what is secondary. Now, if somebody asks you, what is secondary recovery? Tell him it's a process that we use in order to increase productivity of oil reservoir. How? By increasing the pressure of the reservoir. How do you do it? By water injection. So that's the idea. Secondary recovery, water injection is one of them. So this is the answer I put here. Why? Why? So the answer in a brown color. Pressure restoration and pressure maintenance. My asset, my bank account, my money is the pressure. If I lose the pressure from the reservoir, I will lose the production from the reservoir. If the pressure in the reservoir is very small, then I don't produce anything. If the pressure in the reservoir is equal to PWF, the well flow pressure, then no oil will be produced naturally. I lose it. So pressure is very important to be maintained. If we lose it, then water injection is the answer by pressure restoration of it and also maintaining the pressure. So that's one of the aim, is maintaining the pressure. So we have also a word called water injection, and also we have water flooding. So what's the difference? The difference in the sweeping efficiency and pressure buildup. And this slide in front of you, I show the difference. Injection. So I inject the water, this is the injection well, into the water aquifer. That's called water injection. So the water injection well is much deeper than the water flooding well, because go deep inside the water aquifer to build the pressure. A flooding, no. I inject the water you see here in the blue area. I have injected the water inside the oil zone. For example, in Iraq, we have oil zone, such as Mishrif, such as Khasib, such as Yamama. These are oil zones, which is having oil inside them. So if I inject the water inside them, then I call that flooding. But if I inject the water inside the aquifer, I call this injection. So which one is good in building the pressure? The injection is good in building the pressure. Which one is good in sweeping the oil? The flooding is good in sweeping the oil. You see, if I go to that slide, which I mentioned earlier to you, the word injection and sweeping. You see here, disposal and sweep. So the sweep is very good, go with the flooding. So flooding is good for sweeping. But injection is good to restore the pressure, to build up the pressure. And that's the difference between a flooding and injection. Tomorrow, if you write an MSc thesis or a report for final year university, or you are working in the field, you have to recognize between the word injection and flooding. And I hope you have learned that from me now. So injection and flooding, different application for oil production, part of EOR. So the factor considered in water flooding and also in water injection, you need to know the reservoir geometry, the shape of the reservoir. Is it radial, spherical? Is it a fold? Is it anticline? Is it a salt dome? That's important. You need to know the geometry of the reservoir, thickness of it, and many other factors regarding the rocks. You need to know your oil properties, API, water content, GOR, viscosity of the oil, B0, formation volume factor, the PVT data you are using in your study, also important to know if you want to do water flooding. Reservoir depth, because you need to know where is my depth, where do I inject the water, where, very deep, very shallow, I need to know that. Lithology, do my rocks, lithology then rocks combination. If I have in this area, for example, in this piece of rock where the oil is there, here, in this a blue area, or in this blue area as well here, if I have too much shale content, a clay stone, water flooding could fail. Why fail? Because the water, when attack the soil or the mud or shale will swell up, ينتفخ. And if the shale swell up, it will close the permeability. I will lose permeability. So it will be a barrier. يصبح مثل حاجز, cannot move the water. So that's the word lithology. Here in this word, which I mentioned, lithology. يعني التركيبة الصخرية مالتي شنو يصخرون بها. What the properties of my rocks. If my rocks are naturally fractures, here in this rock, I'm injecting water, but the rocks is so much fracture in it. What happened to the water? The water will escape everywhere. We call it water fingering. Same as this diagram I show you here now. And this is a problem actually in certain areas, which is we need to look into and consider. I hope here. You see here, I inject the water in this corner, but it goes everywhere. Why? Because the rocks are fractured rocks, heterogeneous, غير متجانسة. We name this problem as water fingering. So I will not get a good sweeping. The water will run away very fast, leave oil behind. But if you look into this diagram, the water front with polymer, for example, he put some water and mix polymer with it to make more viscous, it gives me better front area, better sweeping area. The water will sweep more oil in this case compared to this case. And that's the meaning and the importance of the word lithology and type of the rocks, which is you need to know. So before you say water injection, you should ask yourself, what are my rocks? Lithology of them, fracture of them, and so on. You need to know saturation, how much oil saturation. They said if the oil saturation in the rocks is less than, make a note of that, write it now on a piece of paper. If the oil saturation in the rocks is 15%, unless, don't do water injection, useless. Water injection will fail, will not give you anything if the oil saturation less than 15%. You do something else and it's better. So important to know as well. And again, reservoir uniform or heterogeneous, and the driving mechanism, is my reservoir water derived or a gas derived? For example, here in this diagram, we call this one a water derived and a gas cap derived, two derived mechanism. Here we call it saturated or depleted gas derived, different approach in this case. So you need to know these things. Therefore, my message for you, I want to be a member in water injection project. What do I need to know? This is the answer in front of you. 2, 4, 6, 7 أشياء. 7 things you need to know. Okay? And what do I need to know about a successful water injection project? This is the answer in front of you. Make a note of it. You need to know geometry, properties, depth, all these things. That's the answer. That's the answer. For any petroleum engineer, whether new graduate or could be very expert. I'm an expert. I have exactly 41 years of petroleum engineering experience, 41, or any older than you. But for me, I still use same principles for water injection. I hope that's clear. Optimum, to make it better in terms of quality. Optimization, how can you do the job at a low cost, high quality, minimum problems? Optimization, you do the work at a low cost, high quality, low or minimum safety issues or mistakes, in other words. So it is also important to think about them when you are building a water injection or water flooding projects. So you think about the oil recovery, how much I will recover, anticipating how much I'm going to recover, maybe 25%. Usually, if you ask me, if I have a full successful water flooding or water injection project, how much I can recover? The answer, you can recover between 15 to 20% of oil in place. خمس المكان, خمس oil, 20%, you are lucky if you can get it out. And sometimes maybe 23%, which is not bad. Very good, actually. Very good as a money-wise. Again, production rate, how much? The investment, how much? All these you should ask. Cost of water. These also important. Economy is important. Is water cheap? The answer, no. The water is not cheap. Water sometimes costs me a lot. And this is important to consider in this case. From where the water? Shall I get from a river, from a sea, from a groundwater? Shall I buy it from other companies supplying to me? These are important to think about them. Of course, you can ask me, what is the best water? ما هو أحسن ماء for water flooding, especially water flooding, not injection. Injection, no problem, could be salt water. But for water flooding, the best water is the low salinity water. Low salinity water. كل ما كان الماء أملاحه قليلة, this is better for flooding, better for sweeping. Low salinity water. يعني no more than 10,000 parts per million salt content, no more. How much salt content in a seawater? About 35,000 ppm. How much salt content in reservoir water? Again, about 35,000 parts per million. So, but if the water for flooding, I prefer to be a bit less salt content. If you can, of course. If you cannot, use the seawater, doesn't matter. When do we start it? So now we learn why. Why we start? We start water injection for the purpose of sweeping, restoring the pressure, building the pressure, and increase the productivity, wash the rocks. All these are factors, reasons. But when we start, for example, if we think about the pressure, merely pressure. Yani his same points here, the same point are here, but I very much concentrate here on the importance of if the pressure of the reservoir being depleted to a small value, then recommended to have water flooding or water injection. Remember that. So the water injection is important and useful if your aim is to build up the pressure of the reservoir. These I already mentioned them, so I pass. I already mentioned these. Remember, I repeat in my slides, even in the university. I teach MSc student at the moment. So for my MSc student, I repeat things for them in order to remember it, not to forget it. So to remember that water injection is important to think about building up the pressure of the reservoir, number one, and number two, to sweep the oil out of the rocks. Building pressure more clear in injection, and the sweep is more clear in water flooding. Do we have some disadvantages? Do we have some challenges? Yes, some of them could be surface, some could be subsurface. We call them a problem in this case. For example, in the subsurface issue, we have, in certain cases, we call it ion exchange, or we call it participation. Participation, يعني ترسبات الأملاح, participate. So if I have salt in my reservoir, such as calcium or magnesium ions, and I inject water with another calcium or magnesium ions, I could have problem of participations. Or vice versa. I have sodium and I'm injecting calcium, I have, or could be an ion exchange. Is it very big? Not very big, but something you need to keep in mind. That could be also cause وحنسميه بالعربي English we call it scale problem, scale ترسبات, and that ترسبات give me formation damage. Formation damage. Remember the word skin factor? If you have studied petroleum, you heard about skin factor. So skin factors come from formation damage. And one of the reasons for formation damage is the scale buildup. What do you mean by scale? I mean calcium and magnesium ions are building up. That's the meaning of it. So keep that in mind. These are useful for you, not only now, even if you graduate and get a job, you need to know these things. One of the problems we face in water injection flooding is the scale issue. The scale built up inside the injection well and the tubing, and sometimes around the perforation area could be blocked because of the water, calcium, and magnesium ions. Other problem people talk about is corrosion, and I'm sure some of you are very aware in corrosion. Corrosion is a big issue in the oil industry in general. In water injection, especially if the water is a salty water, salt content is high, and the pipes will be corroded. The injection pipe, the tubing, the casing, the wellhead, the tank, the injection pump, the impeller of it, and the shaft, these are very much possible to have a corrosion. Then if you have something inside the water as well, dissolved in it, such as H2S, hydrogen sulfide, also this salt very much acidic. So acid, salt, a high temperature will do corrosion, and corrosion will damage the equipment, especially make the pipeline very weak, and also could be very much punctures, مثقب, and that's a big issue. I know some companies, for example, I remember used to go to Abu Dhabi, ADNOC, and still I go to ADNOC, Abu Dhabi, but because of COVID, I stopped traveling as a consultant. And I know in this company, they spend more than 10, sometimes $12 million just to fight the corrosion. Fighting the corrosion is very expensive. So the water flooding, now we know it, water injection, we know it, and the purpose, we know it. I have shown you these two slides as well, and the importance of building up. The pressure of the reservoir is important to keep an eye on. Your injection pressure here or here it must be a bit higher than the reservoir pressure. How much higher? Injection pressure, how much should be higher? They said around 200 to 300 psi. Your injection pressure should be 300 psi more than the reservoir pressure to make it successful and to make the water moving inside the rocks. This example from Saudi Arabia, KSA, Ghawar oil field. And if you heard about Ghawar, this is the largest oil field in the world, very large oil field, limestone, more than 230 kilometers, the length of it. And they have, you see here, about 4 injection stations inside that reservoir. Khuraisi, even also it has one. They have one in Shipa as well, down in the Rab al-Khali. And they take the water here as a seawater from the Gulf. This is Bahrain, High Bahrain. They take the water from the Gulf, from area called the Orena. Very powerful pump. I have visited the place. I go to this place twice or 3 times I went. A huge pipeline. The pipeline حوالي 54-inch diameter, very big pipeline, and more than 500 kilometers pumping the water inside the reservoir. So the water supply is important, very important. With no water supply, there's no water injection. Therefore, it's important to think about it when you decide. You have to think about, where is my water? From where? Do I have enough water? And you should have enough water, much enough, millions of barrels. The rule of thumb, if you ask me, how much I need to inject water, how much? The answer, they said, typical, يعني النموذج الممتاز, 2 barrels of water to produce 1 barrel of oil. 2 barrels of water to produce 1 barrel of oil for the sweeping. Sometime more. If you have cracks in the rocks, you have shale in the rocks, you have very low pressure in the reservoir, sometimes could be ratio 4:1 or could be 5:1, يعني 5 barrels of water to produce only 1 barrel of oil in certain cases. But the typical النموذجي, if everything is good and nice and you have no problem, then it is very much the ratio of 2:1. And that's very important to keep in mind and to have an answer for some questions. What is the best way? Yes, I have this station here. I have a station to inject water. How many wells are used for injection, and how many wells are used for production? Shall I use more water injection and less production, or I use less injection and more production? It depends. There's no fixed answer. But the general answer, I prefer to have 1 injector to every 4 producer. That is standard, typical. يسمونه 5-spot technique. Something like that. يعني I have injector in the middle here, and I have producer in the corners. That's a typical situation. As you see here in 3 dimensions, in the center we have injector, and I عندي بعدين producer on the corners. They call the 5-spot technique. Is that the only technique? No, not the only. I'm just saying, I'm an example. You can read more about it. There is a 3-spot, there is a 9-spot, 7-spot, there is 9-spot, there is scattered, there is the peripheral, there's so many patterns. But I'll just give you example here. The 5-spot is very common and famous in water injection, something like that. Here you see the opposite, here the opposite. Here I have 4 producer and in the center injector. In this diagram, the opposite. I have producer in the middle, and I have 4 injector on the corner. Yani more water, less oil. It depends on the way you choose, the way how much oil saturation left behind, how much pressure depleted. If the pressure depleted is very high, you have to put too much water. إذا الأويل متبقي قليل oil, then you put too much water. So that's depending on the 5 spot, which one you say? Ratio between producer to injector. So it could be 4 a producer, 1 injector. Could be 1 producer, 4 injector. Depend on the way you choose. In the old field, they use this one. In the new field, they use this one. This is that maybe that doesn't. I don't know why it doesn't working. Okay. I recommend for any water injection or water flooding engineer to have a basic understanding of reservoir simulation. Simulation is very important. Before we start any water injection project, it's compulsory to have something. We have something also to consider the reservoir simulation. You have to have a software, could be the black oil software, could be Petroleum, whatever software you have in the company or in the university. Try to use it in order to understand what we call the simulation. You see the movement from one corner that simulates you how much water being used in order to sieve the oil out. The other important factor in water movement inside the rocks, especially in flooding, is very much about mobility ratio, which is faster. If I inject water here, for example, what do I need? I need to make the oil move very fast or the water move faster? The answer, no. I want the oil move fast. The water moves slowly. So that mobility, السرعة, speed moving, equal mobility ratio. Which one is faster? Usually, mobility ratio should be sometime more than 1 to make a good sweeping. Other things you need to be aware about also the displacement efficiency as well as the permeability. If I ask or discuss with you and say in water injection in this slide here in this diagram here, I prefer something called vertical permeability to make the water go up. But here I prefer something called horizontal permeability to sweep the oil. So understand the permeability direction, permeability amount, how many millidarcy there, also important factor for better planning for the process of water flooding. And mobility ratio has also connection with permeability, which we call relative permeability. So understand these or remember these. Remember, if you ask yourself, what do I need to know about water injection, especially reservoir? Permeability is important. Viscosity of water and viscosity of oil is important. The pressure of the reservoir is important. Injection pressure is important. The quality of the water. If the water is not clean enough, it will cause a blockage, damage. So the water should be clean enough. These also talk about the importance of mobility ratio. I may get a better mobility ratio, or better movement, better sweeping at a low mobility ratio. If I can water move very fast, then I have a breakthrough. The word is breakthrough, that means the water escaping, leaving the oil behind. Not good. Is it good to have a big breakthrough? The answer is no. Is it good to have an early breakthrough? The answer is no. I don't like it. A breakthrough, يعني we are losing the water. The water does not do the job. يعني الماء, you inject water from one side and you produce water from the other side and the oil left behind. That's not good. I prefer to have a very slowly breakthrough, take longer time, and small breakthrough. يعني amount of the water leaving the reservoir should be small, not too big. Because if too big, then there is no good sweeping, no good recovering factor. So we mentioned the 5 spot already to you, and the importance of the mobility ratio is important as well. So if the mobility ratio is, here we have it more than 1, we will have very easily breakthrough. But if it is less than 1, we have a better movement. So I prefer to make mobility ratio less than 1. Remember that from me. The sweeping, we mentioned sweeping, if you remember, sweep efficiency. Yani how much you sweep out of the oil contact area, ratio between the contact area. Yani, for example, here we have the sweeping efficiency smaller than the sweeping efficiency in this case. And therefore, I can sweep more. You see here in this block, the sweep efficiency is 82%, if you can read it. The sweep efficiency is 65%. What does it mean? I mean, I have recovered or I swept فقط 65%, لكن هنا I swept 82%. ليش? Why? Because my mobility ratio is small, 1.4. It's 0.4. But mobility ratio high, I sweep less. So the lower the sweeping, the lower the mobility ratio, the better the sweeping efficiency. How can I make the mobility ratio slowly? Some people say add some chemicals, gelatin, polymers to the water. Sometimes you add something to the water to make them jelly. And that's also important to look into. Then we have to think about, at the end of the day, how much water I can inject inside the reservoir. How much? How many million barrels? This is the way they calculate it. If you have some data about your reservoir, you can calculate at the end of the day how many barrels of water being injected at a given time in 1 year, in 2 years, whatever. That's important because you need to overflow or overflood. So some data you need them, such as this is for a gas reservoir anyway, and sometimes also you need the porosity, thickness of the rocks, and so on. That's what you need. If you are working in a water injection or water flooding projects, you need to know how much I need to inject per day. How many barrels per day? This is the equation I put for you. You can use this equation to calculate or to predict how many barrels of water injection per day. In any reservoir, Halfaya, in Fakka, in Gharraf, in Ruwayla, in Baba Gurgur, in Kirkuk, in any oil field in Iraq or outside Iraq. All you need to know this equation in front of you: thickness of the rocks, pebblety, pressure, delta P. Delta P is the difference between the injection pressure and the reservoir pressure. And we said to you today, the delta P usually around 300 psi, about 300 psi. Viscosity of water, relative permeability, wellbore radius, viscosity of oil, the radius of the injector well, and the radius of the oil zone. These could be calculated, could be get from the geometry. You can find them easily. Here we have it in this slide, for example. This is the reading of RO, the R. This is the RO, the value of it. Not difficult to get it. This is the way you calculate RO. For example, here we have RO. Here you have RO. What is RO? Outer radius of oil bank. How can I calculate RO? This is the equation we calculate RO. You got the point? So it's quite important you be able to do that if you wish. And that's useful to be aware about. So for sure, as a history, as a knowledge, as something you need to be aware about. You can see more clearly that the secondary recovery build up the production. You see here in this two curve from A to B to C. I am declining. The pressure is declining and the production is declining. At point C, I start water injection, so I notice the production go up. And then at point D, start to decline. We call it breakthrough time. And at point E, we have finished the projects. So the secondary recovery here between the point C and point E is a secondary recovery. After point E, A, B, C, D, E, F, G, you can say I would use tertiary recovery. Remember when I said to you in the first slide, I have secondary recovery and tertiary recovery? That's the meaning of it. The question comes, does secondary recovery has no end, will never ever stop? The answer, no, it has an end due to breakthrough. So that is something which is need to be aware about and take in consideration in this case. Sorry, Yamama.
Hello, doctor.
Somebody asked me on WhatsApp, say she cannot attend because she need to do registration, or no need for registration.
I'm not sure about that, but we are just opening the Zoom, so I could receive any attendance. So she may consider to recheck her
Anyway,
and she
I
may
don't know the
need
reason
a
why.
passcode.
I gave her the
Okay, I'm
passcode.
sorry for this. She could join us on Facebook.
On Facebook, huh?
Yeah, do you need the link to it? I could post it.
No, I have no time now to talk to her, but she tried and she apologized anyway, but I will talk to her later. She's from India. So we have this case that primary recovery, secondary recovery, the peak value of it, and these are important to take in consideration. So it's a fact, that secondary recovery has a life, starting point and finishing point. And this graph tells you between point C until point E. After that, we have to stop to think about something else. And these stages of water injection, stage A and B, A, B, C, D, and E, which is exactly the same as here, A, B, C, D, A, E. The stages tell us that you are in first stage, you're just building the pressure, you're just filling the gap, you just replace the oil which you produce, replaced by water. Stage B, now you have some interference, tadakhul, between the water and the oil start to sweep. And stage number C, you are filling up the gap. And D is a breakthrough. And in E, you have the end of the project, where you have too much water coming out. We call it here in point E, we stop due to very high water cut, water ratio, capital WOR, water oil ratio. Come very big sometime. I have seen, I went to Canal Suez in Egypt in one project, and they have water cut up to 85%. 85%. يعني كل 100 barrels, there's 85 barrels of water, only 15 barrels of oil. That's the end of the project, too much water coming. So sometimes you need to continue, but for economy. If the economy is not good, you have to stop. So these are the important words in water injection and flooding as well. The breakthrough, at and after. So the breakthrough is the beginning of the water to produce to the surface, the beginning of the end of the project. بداية نهاية المشروع, the breakthrough. That's at breakthrough, number 2. And in number 3, after breakthrough, then you have to consider the water production rate, and you keep an eye on how much water coming, and you will ask yourself when I will stop for good. And in point number 1, before breakthrough, of course, you will keep an eye on how much oil I'm producing, and the water cut to be a small value, and to monitor the pressure build up as well. So these are important stages in any things you need to be aware about. I put for you here some equations to consider. I'm not going to do any calculation with you today because it's master class, not a teaching class, just master, that's for training. But if I teach you, then I will talk about how can we calculate the sweep efficiency, aerial sweep efficiency, and also the breakthrough time, and before and after. So these are the equations here. So this title here, you can mathematically, you can calculate how much being swept, 20%, 60%, 80% aerial, that depend on your data. So there's also a calculation for the vertical. This is aerial, also the vertical sweeping. Vertical must mean water move upward. And that also has a certain calculation for it. As I said, here we are, it has certain calculation. I will not show the equation here, I think, but I'm just saying that some calculations are important in designing of the water flooding and auto water injection, which you need to be aware about. I don't teach here calculation now. I know the calculations. I have done it with my MSc students, but for you, no time to do that. The displacement. Sure, Faraq, what's the difference between sweep and displace? Here we have sweep, and in this slide we have the word displace. Sure, Faraq, what's the difference between them? And sweeping is removing. You are removing the oil from the rocks, regardless of what do I put behind. Maybe I put nothing behind, just remove them. But if I leave some water behind, in this case, we have displacement efficiency. I push the oil because the water wants to take its place in the porosity, in the pore volume. So I have oil in the pore volume, I push it out, and I put water in a state. That's displacement efficiency called. Both sweeping and displacement can work together sometime. If you multiply them together, you get something called recovery factor. So displacement also could be saturation, could be aerial, could be vertical as well. Different way to do about displacement, and also different way of sweeping. So here ED and EA. This is for sweep. This is for the issue of displacement. If you multiply, I have the equation, I think, somewhere. If I don't have them, I can tell you now. The recovery factor is equal to ED multiplied by EA or EV. If you multiply the aerial sweep efficiency, multiply displacement efficiency, multiply them together, you get the recovery factor, enhanced oil recovery. Sweeping efficiency, aerial or vertical, depending very much on porosity, permeability, heterogeneity, and other factors look like that. We have mentioned this slide earlier about the fingering issue. When I have no heterogeneity, not uniforms, so maybe I will lose a good sweeping. To improve, you see here, improve sweep efficiency, I may add some polymer to the water. Can I? If somebody asks you, I'm doing water injection in Halfaya, I'm doing water injection in Ghawar, I'm doing water injection in Rawdatain oil field, can I add something to my water? The answer, yes, you can add. What do I add? You can add polymer, water-based polymer, aqua polymer, or you can add surfactant, sabun, sa'il, soap. These will help in reducing the problem of fingering and give me better sweeping efficiency. Remember these. So I can improve efficiency by adding some chemicals to my water that could be polymer or could be surfactant in order to make it a bit jelly. The oil field depend on the API factor. This polymer we don't talk about. These are, I will just mention very quick to you. These are polymer and surfactant. We name them as the tertiary recovery, tertiary. Thermal, here we have thermal, also tertiary. And usually secondary recovery, as I said to you, water injection or gas injection can take 20%, 30% maximum. But from my experience in the oil industry, if you got 20% recovery, you are lucky. So water injection can recover up to 20% of the oil originally in a place. I have mentioned this factor already, and this is the slide for water injection area where you are targeting the aquifer, and this is for flooding. So this is injection because you inject the water in the water aquifer, in the water derived mechanism. And this one I call it flooding because I'm aiming at the pay zone, the oil zone, the zone with oil inside it. And here I'm building the pressure, but here I am doing sweeping. This I mentioned to you, this is primary. In secondary, you see the blue line. After primary, the pressure depleted. I built up the pressure by having water flooding or water injection. So the curve goes up, and that's an evidence of building the pressure of the reservoir and give more productivity. So it's a fact. It is a fact that secondary recovery can give me more oil. We mentioned the optimization already, and here is different of deriving mechanism, whether it is a gas derived or water derived. I prefer water injection and water flooding to be in a water derived mechanism to give me more power. The other question I can ask, or you can ask me, can I do two secondary recoveries in the same field? That means I do water injection and gas injection at the same field? The answer is yes, as you see in front of you in the slide. They call it combined secondary recovery. You target the red area, and that is very much the gas cap, and you target the blue area, and that's water cleavers, and you build the pressure and get the oil out of the green zone or oil zone. I hope that's clear for you. Of course, more expensive here, but more productivity. Other parameters you need to think about your reservoir in terms of capillary pressure, the surface forces, the injection, surface tension, called wettability, and adhesivity. اكو rocks الله خلقها يسمونها oil weight rocks, and sometimes water weight rocks. oil weight rocks الصخور تحب النفط يبقى معاها. the rocks that love the oil to stay inside, doesn't move easily. واكو صخور يسمونها water based rocks, the rocks which loves the water and hate the oil. معظم الصخور بها potassium وبها clay, we call them a water based rocks. الصخور بها calcium وما بها clay, we call them oil based or oil weight rocks. Water injection, I already mentioned that to you. I mentioned the water injected oils, I mentioned already this one. Costing and economic, I mentioned this word because I'm worried about time. Don't forget the importance of understanding the cost of a project and how much I produce out, how much I spend money for the surface and subsurface. That's important. Mobility ratio, I have mentioned them. This mobility ratio I have mentioned. Injection rate is mentioned. Mobility ratio we mentioned as well. And these are important to look into. How long, what's the distance between the injector and the producer? If I go to the slide. Here we are. I have injector, the blue one, a producer in the green. This distance from here to here, how long it is? They named it spacing, well spacing in name. What is the length for a typical, a wonderful, a successful water injection? That L. How do I calculate L to know how much the space? This is the equation given to me. This is the L, which is you can use in order to find out the distance between the injector and the producer. They said usually it will be around 400 to 500 feet to be typical. But we can calculate using the L. And if I know the L and I know my injection rate, I will know my T, the time, the breakthrough time, how long it takes for the water to move from the injector to producer. How long? كم يوم يحتاج? How many days do I need for this water to move from this injector to this producer, from here to here? How long it takes? 10 days? 40 days? 300 days? That's what I name it in reservoir engineering, in water injection. We name it as the TBT, the time of breakthrough. Typical time should be 400 days, 440 days, 1 year. That's better. Don't make it short. Short, you lose your money. And this graph also to do correction or to do calculation for the saturation, water saturation. You agree with me? We start with small water saturation, but the saturation will be built up, very building up until you reach the peak value. And I need to know, in this case, how much the water front as a ratio. A problem, there's so many problems. Some of them is coming from the injector, such as formation damage, such as the plugging of the perforation, corrosion, damage of the production tubing, scale build up inside the tubing, packer damage. All these are important to think about the problems. So the problems, these I put some of them here. Reaction of water as well. We call precipitation or called ion exchange. That's possible. Corrosion, I mentioned that to you. Fingering, I mentioned this to you. Shell content, which is a barrier for the water to move out. Faulty rocks with faults, seal fault, and also leaking faults, make the water escape everywhere and does not do any sweeping. Water quality, if the water is dirty water, it has bacteria inside it or clay inside it, that will block the rocks in this case. And the NFR, if the reservoir is natural fractured reservoir, NFR, that will make a huge problem in water fingering and heterogeneity, and therefore you will lose your project. I will finish in 2 minutes because time is important for you.
It's okay, take your time.
So we have these also issues need to look into, so injection pressure we mentioned, turbulency and emulsion. You need to understand that in research, because if the water is turbulent inside the reservoir, then you get emulsion. يعني water mixed with oil. فيصير عندك emulsion مستحرم, difficult to separate. Shale content, breakthrough, and after water ratio. Economy is important. If you compare water flooding or water injection with others, here the blue box, if you see the blue box, it's at a low cost and reasonably a good recovery factor. يعني covering a wide range of recovery factor. The surfactant غالي, expensive here, but can recover more oil. The water flooding, what do I name it? I name it secondary recovery. The surfactant, what do I name it? I name it tertiary recovery. So surfactant come after water. In between them, we have CO2 injection or flooding, polymer, thermal for hot or for heavy oil, and the MEOR, which stands for microbial enhanced, or they use the microbes and bacteria to recover the oil. So these are important to keep in mind and useful to keep that in mind as well. I finished my lecture. I got 2 minutes to show you a small animation, a YouTube animation, and then I give the time to question me, if you don't mind. So I will show you
It's okay, take your time.
the animation, and I hope it works.
Inshallah.
So we have to go to share. Where is my diagram? No, he's here. Okay. Just 1 second. I'm just learning my technology, my IT.
It's okay.
My computer playing games. I hear this one. Something wrong with my computer?
No, it's okay. You could go to share from Zoom. You may open
Yeah,
the
but
Zoom.
I have something coming on my screen, which disturbing me.
Okay. Take your time. It's okay.
Why? Something wrong. Okay, now I will rotate it around. Okay, I need to get a share here. A new share.
Okay, I think
I'm going to share it now. You have to see it now. Are you seeing it?
I will inform you if I do. Right now, I'm just seeing your. Yes, we do. I think you should zoom it.
You see the it's an animation anyway.
Yeah.
Okay.
Yep, we do.
Okay. So in this animation, he tried to show the water injection process. First of all, he takes the water from groundwater, the blue line. He takes the water from the groundwater, natural water. He will put it into a tank on the surface. That tank used for treating the water supply tank we call it. So the water come here, settling tank, remove any sand particle from it. They put to kill bacteria, whatever, and then they pump it from the surface down into this well. This is injecting well. This is the 5-spot technique. One in the middle is injector, and 4 wells in the corner for a producer. That's a 5-spot technique. So you have to water supply, a groundwater, put in the tank, treat the water, make it clean, pump station, pump it in a pipeline inside the reservoir through the center point, and you have 4 producing surrounding. The water will remain inside, you see the blue area, and the oil will be reduced. The black pipeline of the oil. And you see this blue area is growing. We call it sweeping efficiency by displacing the oil and bringing the water in the state.
Okay. I think you stopped the sharing because you are not a host or co-host. So if Ali hears me, please raise Prof. Hussain Ahmed to be a co-host with us if you are still online.
Yes, I am. I will.
Okay, I also appreciate that. Thank you.
Sorry about this. So I wait
no worries. It's okay. No worries.
I wait to be a co-host so I can bring my slides to you.
Yeah, you have to be a co-host because we didn't give a permission for you. Yeah, it's okay.
Okay, I think I am now. Share, so I share with my view. Yeah, thank you very much. I'm sharing now. You see the slide?
Yeah, we do.
Okay, now, so that little animation I mentioned to you, and as I said to you now, I'm opening the session for any question and answer you want. I thank you very much for listening. I have taken about 9 minutes from my time, extra from my time of lecture.
That's so fine.
So you have about now half an hour to question me if you wish.
Yeah. So hello again, everyone. We are in a Q&A session. For those who hear us from Facebook page or from Zoom right now, the voice you are hearing belongs to Yamama Hassan, which I am a fourth stage petroleum engineering student, and I'm the vice president of the SPE student chapter for American University. So I would thanks.
Yamama, some of the audience are raising hands, so start with raising hand.
Yeah, I see. I would just take this few minutes to thank you and thank everyone joining us, from professors, doctors, lecturers, students, employees, graduations, and everyone here. We're just so pleased to have you and holding this lecture and staying with us till now. I think we're gonna be taking those who's raising their hands, and we're gonna be back to the rated questions. So the first one gonna be Ali Hadi. So I will give you an unmute, so please talk.
Thanks, Mrs. Yamama, and thanks to the Dr. Hussain. It's very much appreciated lecture, sir. I have three questions, please. One of the question is, you said how much water injection, in addition to the question IW water injection, can we use the B total, the oil formation total, to determine how much oil barrel that we produce from the reservoir and inject equal water to the reservoir to sustain production? The second question, if we use the low salt water, do we need it to water compatibility? And the third question, I think you were working at Rumeila Oilfield. I'm in Oilfield Rumeila. So the water injection, they're using just straight line water injection wells. Is this strange or is normal?
Okay, thank you, Ali. For question number one regarding, can I use how much oil in place as indication for how much water I inject? The answer is yes, you can. We call it a rule of thumb. So you make a rule of thumb. You say, for every oil in place, I will inject 2 barrels of water. So if I have 1 million barrel in place, I will inject 2 million barrels of water. You can use that one, not accurate, not a wonderful one, but something roughly give you a rough idea. But of course, the best accurate amount to be taken in the equation I show you, which you can use it to calculate. I'm looking for it, and that is useful, for example, in this case to consider. But the answer, yes, you can use this is a water cumulative equation, or you can use how much oil in place. Or you can use a production rate. If you say, I'm going to produce, for example, I produce 100,000 barrels of oil per day. So let me inject 200,000 barrels of water. You can also do this one, either cumulative or daily production. You can, as a rule of thumb. 2 barrels you are using, not 1 barrel, is one for displacement and the other one is for sweeping, especially in flooding. In terms of Rumaila, they use the line pattern, nothing wrong with that as well. Line pattern is usually used in old oil fields, mature oil fields, they use the line one. The 5-spot is good for almost a brand new reservoir. And the other question you asked me about low salty water, yes. The low salty water is recommended because give you a better sweeping efficiency. But if you don't have it, then use a seawater or formation water. I prefer to use a low salinity water to get more sweeping. إذا إيدك بها دهن جريز تغسلها بماء المالح أو ماء بحر أفضل لو تغسلها بماء الحنفية النقي أفضل. ماء الحنفية النقي أفضل في ذات الزيوت. Same thing with rocks and oil. But if we don't have them, then we can use groundwater مثل ما شفنا بالانيميشن, or we can use seawater or salty water. العراق either use river water or use maybe water supply اللي هي المياه الجوفية, groundwater. Thank you.
Thank you. If you don't have any questions, Mr. Ali, we are gonna to move on for another one. I will give the mic for Mr. Saif Samir. I will give you the unmute, so please talk.
Thank you, Mrs. Yamama. Good evening, Doctor. Hope you're doing well.
Alhamdulillah, Samir. Thank you.
As you earlier mentioned in the lecture, you said about the equation to calculate the time to breakthrough. So my question is, in which way calculating time to breakthrough could help us? And so, how could he help us?
Knowing the value of time breakthrough, it tells you exactly the length of the project. How many years this project will be continue with me, and that's the importance of knowing the this one, the time breakthrough, to tell you how long the project will stay with me. So it helps you in terms of predicting the life of the project, as well as it tell you how much water you will inject, because you know I'm injecting, for example, 1,000 barrels of water per day. If I know my breakthrough to them is 4,000 days or 400 days, so 400 multiplied by 1,000, so I need today to use 400,000 barrels. So that and that way useful for you, life of the project, and also it will be an indication of how much water you need to inject, if you know the injection rate.
Okay, thanks, Doctor. My second question is, if we have a high permeable reservoir, so in that case, how we can deal with it in water injection or water flooding project? How we can perform water flooding project in these reservoirs?
Yeah, this is a good question. One of the problem in water injection or water flooding is the high permeability. I don't like her. Very high permeability can give you a fingering issue and can give you an early breakthrough. الماء will run very fast through the rocks and leave the oil behind. I'm just looking for the slide of the breakthrough, and that is could be something we don't like. How can we overcome that? I said to you, add some gel additives for the water. You may add polymer. You see in this diagram, can you see this slide? You see here, this water, this water with no additives, with fingering and high permeability, and this same water with polymer. So I add not very much. You add a half kilogram of polymer powder to every barrel of water. كل برميل مي تضيف عليه نص كيلوغرام من الباودر of polymer نصف كيلوغرام and you mix it very well and inject it. By this way, you kill the fingering and you make a nice front. You see the slide?
Yeah.
So that's the answer. In high fractured, high permeability reservoir, don't use water on its own. Add some additives to water such as polymer. يسمونه water. يسمونه aqua polymer. AQUA polymer. A water-based polymer. أو أضيف له surfactant. صابون سائل كمية معينة. هم كمية كبيرة. They add half a liter صابون سائل for every barrel of oil, of water. And they inject. By this way, you are controlling the fracture of the rocks.
Okay, thank you, Doctor.
You're welcome. Any more questions?
Yeah, I think we got another question from Mr. Muhannad. So, Mr. Muhannad, I'm going to give you unmute, so please talk.
السلام عليكم دكتور.
عليكم السلام حياك الله.
دكتور سؤالي الأول هو أنا مهندس حقن أو مهندس عمليات بحقل غرب القرن 2 سابقا عملت بالرمى وعندي أسئلة تقريبا 5 أسئلة على المحاضرة. السؤال الأول هو ليمتى نستخدم بالضبط يعني الحقن عملية حقن الماء بحياة المكمن أي مرحلة بالضبط نستخدمه؟
We use it into a clear depletion in the pressure of the reservoir. إذا شفنا ضغط المكمن أصبح قليل وأقل بكثير من قبل. In other words, ما عندي PWH. الويل هيد بريشر ما بضغط عالي أقل من 150 PSI. هذا indication of something wrong in the reservoir. أنا خسرت البريشر ما جاي يصير ضغط عالي. النفط ما يوصل إلى رأس البئر تحت ضغط عالي 150 PSI أو أقل. In this case, I have to make a team. We study and you say we need to do water injection. That's one. Number two, if the production rate, أنا عندي ضغط بس ما عندي production rate عالي. I'm not going to take any oil out. الإنتاج مالتي قل يوميا. Every day the oil production is decreasing. شنو أقول نفسي؟ أقول عندي oil عندي ضغط بس ما جاي يجي الأويل because my sweeping efficiency is not good. So I do now water flooding. So these are two indication of a pressure wellhead reducing أو الفلورا جاي يقل عندي وما عندي oil. الويل لوجينج عندك oil أنت وعندك ضغط بس الأويل ما جاي يتحرك. You need more mobiles, so you do water flooding.
تمام دكتور. السؤال الثاني ما هو أفضل أنواع الحقن للحقول الجنوبية؟ يعني الحقل اللي جاي أعمل به أنا حاليا حقل غرب القرن 2 اللي ما أخذته مستثمرته شركة الأويل الروسية. نفط API مالتنا تقريبا 22 يعني هيفي أويل. شنو اقتراحك؟ بوليمر CO2 ما هسه احنا جاي نستخدم الماء بس ماكو يعني هاي efficiency displacement or displacing.
Good. الووتر انجكشن بشكل عام كمعلومه لك يا مهند وسولف بها بكل مكان suitable مناسب اذا كان API مالتك 30 فما فوق. الووتر انجكشن wonderful اذا API 30 فما فوق يعني medium to light oil. من يصير عندك 20 22 25 API الووتر يشتغل بس ما يشتغل بكفاءه. In this case I keep water but I add to it some surfactant. صابون سائل كميات قليلة معينة because that will help in washing the rocks. بالضبط أنت إيدك بيها دهن جريز وجاي تغسلها بس بالمي مي عادي. المي ما طلعها قسم منها شيء يبغى الجريز. تحتاج تاخذ صابون بإيدك حتى تشيل الستيكر. Same idea. Water will remove some of oil but not all of it. And therefore my advice if I am Luke oil consultant I will tell them that please add some surfactant. أكو أنواع كثيرة منهن. I got some names as well. Trade names أسماء تجارية. You can add them a small amount مثل ما قلت أول مرة أنا half a liter نص لتر من السرفكتنت لكل barrel of water injected. فتحسب يقول أنا عندي 1000 برميل احتاج الى نص كيلو، يعني 500 كيلو غرام، نص طن من السرفكتنت اضيفه وانجكت. اذا يقول غالي if this expensive or don't have money for that, they can use even half of it, يعني quarter a liter. But this is the best way. That's one way. The other way is heating the water. كان انا اسخن المي نفس المي بس ما حقنه كما هو. I heat it up. اخليه في مكان بهيتر شويه اسخنه up to maybe 50 degrees centigrade. مي دافيه اسوي. That also will be useful to sweep the oil. So either add chemical or you add thermal factors. CO2 ما تقدر تضيف، ما يفيدك اطلاقا، بس يضيفك هو السرفكتنت يفيدك، والبوليمر يفيدك كذلك. Any question؟
تمام دكتور. السؤال الثالث، ما هو نوع الحقن المفضل لكل طبقة؟ مثلا احنا راح نحفر بالسنوات الجاية يمامة بحقل غرب القرن 2 3800 متر او 3480 تقريبا الانترفال ديبث مالتها، ومشرف يعني زبير انا حافر ابار بالجنوبيه الرمال الجنوبيه والشماليه. برايك انت يعني كاكسبيرينس عندك زينه، شنو نوع الحقن المفضل لكل طبقه يعني، وفيدنا بالفيزيبيليتي ستدي؟
وبما انه انت بس عندك حاله بالعراق، حاليا بالعراق ما عندهم غير ووتر فلودنج ووتر انجكشن، ما عندهم غير حقيقه، حتى غاز انجكشن ما يسوون. ف the base in this case هو الووتر نفسه regardless of the rocks depth. The depth of the rocks whether it is يمامه او مشرف او خصيب او اي اسم اخر لل production formation. The challenge بيها two challenges. One is the temperature of it could be high, and also the pressure of the reservoir. ونمبر 3 هي الليثولوجي. الليثولوجي يعني التركيب الصخري، is it clay, is it heterogeneous, homogeneous إلى آخره. So you have to have a good understanding for the rocks reservoir properties. بس بشكل عام هو الووتر، بشكل عام ووتر. يبقى السؤال الثاني، اكو سؤال قبل شوي سألنا احد الزملاء قال water compatibility، تجانس المياه. If my water I'm going to be compatible يتجانس يقبل، فتعمل دراسة للآيون water chemistry. How many ions of calcium, how much concentration, how much sodium ions, how much the concentration of it. If I inject water and I have already calcium ions, could I have participation ترسبات scale build up. بس كجواب عام يعني جواب إلك بشكل عام there is no specified case we say انه يعني هو water يبقى نفسه، بس المطلوب what يعني the question should be like this. السؤال يكون هكذا: ما هو علي اللي ادرسه؟ What should I study if I change the pay zone or the injection zone من مشرف الى يمامه، او من يمامه الى خصيب، او الى خوره، او الى زبير؟ What should I study? You should study the rocks, the pressure of it, temperature of the rocks, and the water compatibility. And then you decide. So you have to do some lab work. بعض الشغل بالمختبر تعمله قبل لا تعمل water injection. I hope that's the answer.
تمام دكتور. عندي بعد سؤال أخير. احنا عندنا سيناريوهات قبل لا نبدي حقن، يعني طريقه نوع الحقن بحقل غرب القرن 2 للمثال. كانت عندنا سيناريوهات ثيرمال انجكشن او ثيرمال انجكشن، ووتر انجكشن، وسي او 2 انجكشن. صار البريفبل اكشن او البريفبل اوبشن للاختيار انه الووتر انجكشن، بينما هسه بالمحاضره او انا قاري سابقا او باحث عن هاي المعلومات، الثيرمال هسه باحد السلايدز بالبرزنتيشن مالتك الثيرمال بفيزيبيليتي جدا عاليه وافضل كرفك ريكفري افشنسي بي. ايش عجب يعني ما استخدم؟ شنو السبب ما يستخدم؟ يعني شنو الصعوبه بي؟ او يعني حسب رايك انت.
اي مهند مو مهند.
نعم.
شوف ما هي بس هاي سلايد امامك، شوفها الثيرمال يعطيك اكثر من 50% ريكفري. شوفها. Do you see the slide؟
نعم دكتور. اي
فنعم الثيرمال يعطيك نسبه كلش عاليه. شنو السبب ما يستخدمونه؟ الثيرمال يستخدم حاليا بالكويت، حقول الكويت حق الرذقه اللي هو حقل جنوب الرميلسي يسمى حقل الرذقه يستخدمون ثيرمال، وبالسعوديه يستخدمون ثيرمال، وفي عمان يستخدمون ثيرمال، خصوصا النفط الثقيل. اي نفط بAPI 22 وانت نازل الثيرمال ممتاز جدا له، اللي هو هوت ووتر او كود ستيم بخار. لكن المين ريزن فور ذات هو الموني cost. In order to heat the water and to change it to steam, you have to pay money for the heaters. Number two, the nature of the injection well. يجب تغيره injection well، تغير الكيسنج، تغير البرفوريشن، تغير الباكينج، لانه حراره عاليه واكو بعض الحقول ما تحمل ابار ما تحمل حراره. So you have to use a new well with a new integrity. Well integrity we call it. فهذا اذا هي الميجر فاكتور هو الكوستنج. فاذا كان شركه اجنبيه وفي تفكيرها انه تنتج اللي تنتجه خير وبركه، عمر هاي الشركه الاجنبيه ما تتألم على البلد، عمرها ثابت، شيء منطقي. فيروحون الاسهل موجود هو الووتر. هم يعرفون، علمائهم وخبرائهم يعرفون انه الثيرمال اكثر فائده للانتاج، ينتج لي اكثر، بس يقول انا طالما ما حد يعني مدوخني فانا استخدم ووتر. فيس I agree with you if you are a consultant او مستشار او شيء، تقول لهم هو الثيرمال يكون افضل، خلينا نسخن الماء قبل ان نحقنه، اقل شيء نرفع درجه الماء الى 50 درجه مئويه فما فوق يكون افضل. تقول لهم انا دارس ومتعلم وفاهم واعرف النفط الثقيل ابو 22 API او 21 او 20 افضل له هو الثيرمال ريكفري. الثيرمال يعني الحار، الماء الحار في اقل تقدير. فنعم جوابك صحيح، او تخوفك صحيح. التخوف هو الشركات تخوف من الكوستنج، التكاليف.
شكرا لكم دكتور ولجميع المشاركين في هذه.
حياكم.
Thank you, Mohammed. Thanks for your sharing and your questions and the answers. I'm gonna just stopping the flowing of questions voicely. I got a question that written in the Zoom chat. Said, what's the difference between stable and unstable flooding? So after that, I'm gonna give the permission for people to talk.
الستيبل unstable water flooding واضح جدا. stable flooding where you have a clear front, there is no any breakthrough, no any fingering. يعني مثلا أو هاي الفيجر مثلا ده this diagram هذا أنا أسميه stable، هذا أسميه stable. الفرونت واضحة جدا على شكل قوس، doesn't go everywhere, a good sweeping, I have a good homogeneous reservoir، ما عندي cracks، ما عندي fractures، ما عندي fingering، ما عندي shell، I have no shell, no fingering, no fractures, I have no clay, the water move very stably, sweeping all the area. I call it stable water flooding. لكن if I have fingering, if I have heterogeneity, that's mean change in permeability, I have fractures, I will call it unstable. Very simple. As
okay,
well as the pressure. Okay.
Okay, thank you. I really have a lot of questions that is written from Facebook and Zoom chat. I will be just allow for one person only to talk, and then I'm gonna be asking the questions that are written in whether in a chat or in a Zoom page. I will gonna welcome Mr. Mohammed Hamid Darwish. He's the representative of our fourth stage petroleum engineering from University of Maysan. Most welcome. You could talk now.
شكرا ست يمامة. السلام عليكم دكتور.
عليكم السلام.
دكتور سؤالي بدون زحمة، على حسب علمك اكو حقول تجاوزوا بها السكندري ريكفري وبدأوا بالتيرشري ريكفري؟ واذا اكو شنو الاسباب اللي يخلوهم يتجاوزون هاي المرحلة ويبدون مباشرة بالمرحلة الثالثة؟ وشكرا.
انت تسأل حقول بشكل عام مو بس العراق؟
اي دكتور.
بشكل عام نعم اكو حقول. there's so many oil fields now they are in tertiary. There's an oil field in ابو ظبي اسمه حقل الرذقة، سوري ضبعية. north east of باب جنوب في غرب west of أبو ظبي. إذا تروح لأبو ظبي كالسيارة من أبو ظبي إلى هاي الحقل حوالي مسافة 150 كيلومتر. They are using now tertiary recovery, and namely they use the CO2 injection, ثاني أكسيد الكربون. There's also another field in Abu Dhabi called Asab oil field. They are using polymer. After they finish water injection, now they use polymer. شنو السبب؟ سؤالك شنو السبب؟ The idea I said to you in my slide, in my lecture, if you attend first my lectures, water injection and water flooding will not work at a low oil saturation. فإذا كان oil saturation 20% فما دون 15% 16%, water flooding doesn't work very well, will be useless. So we have to think about tertiary recovery, منها البوليمر surfactant والCO2. هذا السبب حقيقة. mainly saturation يعني ماكو saturation كافية in order to recover oil.
Okay, thank you, Doctor, for your answer. I'm really sorry about that, but we got a lot of questions, so I'm sorry we're going to take your time.
Okay.
Thank you. Just let me go to the first one. Okay,
I am here to serve everybody. I am here to serve everybody.
Thank you. We so appreciate your efforts. We're glad to have you with us anyways. It's an honor, actually. So the first question I had is, what's the use of low salinity water flooding? How does this affect on our the production?
Okay.
Sorry,
low salinity water is very good in reducing the adhesivity, الالتصاق، الصمغية. يعني الحالة الصمغية للنفط الخام تنتهي if we use low salty water. الأويل is sticky، يلتصق بالصخور، be adhesive، بمادة صمغية. So low salt water, remove it. حنسمونه IFT, reduce the interfacial surface tension. يقلل الشد السطحي between the oil and the rocks. هاي ميزة معروفة بالlow salt water. Number two, low salt water also can have better mobility. يعني sweep better and sweep more area in this case. السؤال الثاني كان الجزء الثاني من السؤال شنو؟
Okay, just give me a second. How does this affect on our production?
Yeah, of course, it will increase the production for sure. It give you better production rate because it give you a high swimming efficiency. أنا أعمل مثلا for my research at the university, I use salt water and I use low salty water. I notice low salty water can give me recovery factor up to 65%. بينما salty water give me only 45%. So 20% more production rate using low salt water.
Okay.
أنا عملت بحوث كثيرة على هالمجال وأعرف السبب يعني أعرف I know what's going on.
Okay, great. I'm just sorry for everyone. I will just receive the written questions and the most important things. So I will just go on for the next question. The next question is the first. Thanks for your lecture and your time. Could you briefly explain the main problems and mechanisms associated with carbonate water injection, CWI, in field projects?
The major challenge with carbonate water saturation هو subsurface corrosion and also surface corrosion. That's the only major challenge because these carbonate water are acidic behavior. The pH value مالتها أقل من 7. That's the major reason. The carbonate water is good because it will behave as an acid and it will remove the clay and it will remove the scale buildup. So it gives me better channeling and better movement for the water inside, and therefore the recovery factor of it will be higher compared with the normal waters. But don't use it everywhere. Don't use it into carbonate rocks sometime, which is with kind of shell inside them, or don't use them in sandstones. But generally, carbonate water is good by having better channeling, I can say, removing some of the dirt from the rocks, and also the major challenge is the corrosion issue, both on surface and subsurface. Thank you.
Okay, thank you. I got another question. Okay, I'm sorry, another time. I won't say the names for those who ask. I will just ask the question and you receive the question, the answer. So please be tuned and follow us with the questions to find your question answered. The next question said, can pump the underground water directly to the production zone in the same well, dump flowed.
Groundwater in the production zone directly injected, you mean? He means we inject the water directly into the pay zone or from the production zone? Yeah, that's what I understand. I didn't understand the question very well, but let me understand. I will explain.
Okay, do you want me to read it for you?
Yeah, if you can, because I didn't understand what does he mean.
Yeah, okay. Okay, can pump the underground water directly to the production zone in the same well, dump flood, yeah.
Yes, the answer is yes. And this slide in front of you, I put the slide here. I can use the groundwater or the water produce water and the separator the surface. The three-phase separator take gas, oil, and water. How the water produce water and the separator produce water? If I treat it a little bit, make the pH value equal to 7, I remove the bacteria from it, for example, can I use it to be re-inject inside the well, inside the pay zone? The answer is yes. Even better, because منهم وإليهم, same physical chemical properties, and therefore a slide like this راح نسميه احنا water flooding, and it works better. I recommend that actually. Instead of throwing the produced water somewhere else, just pay little money, clean it, treat it, and re-inject back again. They said in terms of economy, to treat a produced water, 1 barrel, it costs you about 50 cents, $1 to treat 1 barrel. So you can't pay money for that and make the water is good for you. They use it actually in Kuwait, and they use it also in Oman. They are producing they are injecting the produced water. Thank you.
Thank you. Okay, I got another question. I think it's from Facebook. Can we make injection closed process?
Yes, you can. That's the answer we have said already now. If I inject the water, and then in the surface I got the separator. I don't have a slide. Maybe I have a slide on that somewhere. If I inject the water, and the water then come out to the surface from the separator, I treat the water again and re-inject back again. It's a cycle. It's a closed cycle. I'm just looking for a slide for that. I have no slide, maybe.
That's okay. Take your time.
Yes, it is. It is. I have seen one slide on that. If I can.
Okay, I would take this few seconds while we were searching for the slide. Please, if anyone posed a question from the beginning of this lecture till now, please don't post it again, because we just captured every question and we try to ask all of them as much as possible. We don't want to take much time from doctor. We just so sorry about this.
Okay, you see, for example, Yamama, and this slide, I make it a bit larger. The oil will come, and the oil separator, the water here, which is at the bottom of it, I can take it back again. In the middle, I do treatment for it, and then I inject it back again. So it's a closed cycle, yes. And that's better, even better. Nowadays, most of the new projects are thinking about a closed cycle water. So they don't damage the environment, and they recycle the water, and they don't pay too much money for buying the water. Buy a water is expensive nowadays. In certain companies, for example, in the Europe, sometimes you have a water supply company. يعني المي الوتر injection تشتري من مكان آخر. You pay money for it. So recycling is good answer for stopping and make it more cost effective.
Thank you. The next question I will say it from Rowan. ما هو البرنامج المستخدم لتحديد المسافة بين بئر الحاقن والإنتاج؟
As I said to you on the slide now, one of the equation I gave you the letter L, capital L, we name it as the spacing between the injector and the producer. If I get a slide, our equation. So this depending on the injection rate, mobility, here it is L. هذا L هو الspacing. هو المسافة ما بين الانجكتر والبروديوسر. يعتمد على الانجكشن ريت IW، يعتمد على البوروسيتي، الكونتاكت اريا، الساتوريشن اوف ذا ووتر، الووتر فرونت، ويعتمد على بريك ثرو تايم، timing, speed of water, speed of oil inside the rocks. So that will be depending on very much on the thickness of the rocks, pressure injection rate. All these are important factors. Saturation already. Saturation is علاقة بالfilling. How many days you need to fill up the space of the porosity, displacement. فهذا هو the way they calculate. But the typical space يعني النموذجي ما بين الانجكتر والبروديوسر، يعني if I look into this diagram ما بين الانجكتر والبروديوسر مسافة التيبيكال هو حوالي 400 to 600 feet المسافة ما بيناتهم تكون عادة، حتى يعطيك better response, better recovery، ما يروح الوتر كل مكان. بس how to calculate, what's the factors? The factor of thickness of the rocks, porosity, permeability, the water injection rate, the saturation of water, all these are important factors to consider. Any more?
Thank you. I got plenty of questions. I'm real sorry about this. So we're going to take your time.
Okay.
Okay, so the other question said, can you please re-explain the difference between sweep and displacement efficiency? You say that displacement when water displaces the oil and take its place, but what about sweep? What will take its place?
Good questions. And sweeping هو contact area. The sweeping efficiency is the ratio between the contact area to the total area. يعني مثلا if you see in this slide, this one, you see the total area هي البلوك هذا كامل which made of blue and green. So if I take the ratio of the blue to the total area, blue plus green, that's what I name it sweep efficiency. If the total area being contacted by the water, هذا يسمونه sweep efficiency, aerial one. مثل هذا. But displacement لا. Displacement, how many barrels of water you inject to displace how many barrels of oil. So the ratio between how much oil to how much water injected. فتقول أنا أنتجت 500 barrels of oil, but I injected 600 barrels of water. فتكون الافشنسي او displacement هي 500 على 600، يعني 500 barrel of oil produced, but I inject 600. So that's a ratio between quantity. You see the word amount كمية. أما بالسويب لا area مساحة contact area. هذا الفرق ما بين كمية وما بين مساحة. الفرق ما بين sweeping و displacement.
Okay, great. I would just want to mention that the lecture is streaming on Facebook right now, and it's going to be stayed on our website, our page on Facebook, and we're going to upload it soon on YouTube as well. So please follow us on our official platforms. I got a question with it, with your, what was you saying? Sweep efficiency, does it depend on oil properties?
Yes, sweep efficiency very much depending on oil viscosity and oil adhesivity. If the oil is very viscous, high viscosity and very adhesive, يعني صمغي يلزق شلون حنقول مثل القير مثل التار, then sweep efficiency will be very low. So the sweep efficiency will be affected on viscosity and adhesivity. If the oil is very viscous, high viscosity, لزج, and it also very adhesive, ميلتصق, then the sweeping efficiency will be low. And therefore, sometimes to make sweep efficiency high, they add some chemical to the water. They add maybe polymer or surfactant, or make the water a bit hot water in order to remove the adhesivity in this case. I want just to, that's different lecture here, but I try to find
it's okay.
something to use that one. Yeah, so the answer is for you, sweep efficiency, depending very much on the viscosity of the oil. In other words, mobility ratio. والmobility له علاقة بالviscosity. You see, mobility ratio له علاقة بالsweeping efficiency, والmobility نحسبها بحساب الام له علاقة بالMO, viscosity of oil.
Yeah, I got another if you're finishing.
Yes.
When we should stop the water flooding?
We stop the water flooding once we feel that we have a breakthrough, more water coming to the separator. I have noticed too much water coming to the separator, the surface separator, and that is the beginning of a breakthrough. So if, in January, I have 10% water saturation, in February 20, in March 30, in April 50, so then I would think, oh, water is coming, too much water coming. Here we are, yeah, mama. You see here,
Yeah.
I stop where? I stop at point E.
Yep.
So I start at point C for water injection, and I continue. Maybe this is the x-axis, the time axis. Could be 1 year from C to D. It could be 2.5 years from D to E. So total is 3.5 years. Then I say, oh, too much water coming. And Q naught, very much little oil. I would say that's near the end. You see here, near the end of the project. So I have to stop. So I stop if I see there is no any feasibility, any economic in it. Too much water coming. So I stop.
Yeah, so I have another question. Said, is the economic limit of secondary RIC is higher than the primary RIC? Okay, recovery.
Secondary for sure is higher than primary, because in a primary recovery is nature, is Allah. That's one primary. You don't add anything. That's the reservoir, is a branch reservoir. You have pressure into it, and you produce from natural derived mechanism. The cost, for example, in Iraq, Kuwait, Saudi Arabia, for a primary recovery to bring the oil to the surface, no more than maximum $2 per barrel. But once you do secondary recovery, you add another $2. فيصير $4. يعني هنا أنا إنتاج مالتي يكلفني $2 بالبرميل، هنا يكلفني $4 بالبرميل. Because I'm adding a new expenses, water treatment, water additives, corrosion inhibitors, pumps, pipeline, and so on. So I'm more costing in this case. So yes, secondary recovery more expensive. Tertiary even more. يعني السلايد الأولى شوفتكم إياها أنا، هذه green area even more expensive. مرات بالCO2 يكلفك حوالي $5 على كل برميل للCO2 إضافة للبرايمري مالتك. فإذا كان البرايمري $2 and you add another 5, so it will be $7 just to produce 1 barrel as a cost. So the costing will be adding and adding. Cheap in primary, medium cost in secondary, high cost in tertiary.
Yeah, great. I think we're gonna be the list of questions. How cost injected 1 barrel water in injection well?
how much it costs me to inject 1 barrel as money? Water injection 1 barrel?
Yeah. Of course.
Okay. Okay. There is. I have. Yeah. I have some
Yeah.
calculation, but in different slides, not for you, for my project. It costs. Yeah.
It's okay.
Depending on the depth of the reservoir. But it costs you on average as money wise, for water injection, it costs you around 50 cents, half a dollar for every bottle of water you inject, including water treatment. كل برميل water يكلفك نص دولار لكي تحقنه داخل البئر. Average.
So the other questions, polymer, the water, and it's
your voice is cutting.
0.5 kilogram. Okay, it's just because of internet. Clear now?
Yeah, Mama, your voice was cutting off. Can you repeat?
Yeah, yeah, just I don't know if it's now. My voice clear?
Now clear. Continue. Ask me again.
Okay. What type of polymer that you can add to the flowed water and is economic at a half kilogram beer barrel?
There's 6 type of polymers. اكو يسمونه ASP اللي هو aqua surfactant polymer، اكو water based polymer، اكو oil based polymer، نوع يسمونه thermal stable polymer TSP. The best polymer I go for is the water based, the aqua one, AQUA, and this is cheap in price, not very expensive. And you can add, as I said to you, half a kilogram, a pound, 450 grams, good half a kilogram, for every bottle of water you mix with. Actually, I'm wrong with I say water. I can say better. This is the way I can say to you. Every half kilogram of polymer will recover 1 barrel of oil. That's the ratio they use. 1.5 kilogram of polymer mixed with water can recover 1 barrel of oil. فإذا البوليمر يكلفني مثلا تكلفة السوق is $3. I produce 1 barrel، البرميل سعره بالسوق $40، so I'm making good money. يعني I spend $3 but I get $40 for it. You got my point?
Yep. So this is gonna be my last question for you tonight.
Okay.
What will happen when much water produced with the oil and stopped the pumping? What will happen for residual oil? Can it left behind water and trapped?
Yes. What happened to the water produce? It's up to you. If there's too much water produce, either you can treat it back again, treatment by removing sand particle, by control the pH value, make it 7, by remove bacteria if there's any bacteria, and then you inject back again into the wellbore. Up to you. اكو نوعين من wellbore. اكو wellbore for injection. There's wellbore used for يسمونه disposable water wells. آبار النفط، آبار المياه المستخدمة اللي ما نحتاجها. So that's one way, is you treat it and put it back again into the reservoir, but into a certain area of the reservoir. You can use it as water injection, so as we say, recycle again, closed cycle. Or you can throw it away if you wish, in the sea or in the river or in the land, but after good treatment. For example, I have seen in Oman, they throw the water into a big lake, صحراء، وعملوا بالصحراء حفرة كبيرة جدا, a big, like I can say the size of a city, and they filled with that water, وأصبح مثل بحيرة تجمع بها النباتات والطيور وأصبح مثل منتجع. That could be one. A residual oil, the second question, what happened to residual oil is up to you. يعني إذا بقى الأويل 15% باقي and the water cannot take it out, it's better to use something else to take it out. Could be CO2 and some tertiary, could be polymer, could be surfactant, could be steam, whatever you are thinking about tertiary. Or إذا عندك فلوس هواية, forget it. Then can it left behind water and trapped? Better no, actually not. Better is to take the oil out using a tertiary recovery. That's what I recommend. اللي هي عبارة عن CO2 أو polymer or surfactant. Surfactant الصابون السائل. That's also important.
Okay, thanks for your answering. You did a great job today.
واحد
We're
سؤال
sorry
آخر
for
سؤال
correcting.
أمامي هنا.
Yeah, I
شخص
see it.
مرتضى تركي.
Yeah. Yep.
How we are dealing with oil weight rocks.
Yes,
The
during
oil weight
flowing
rocks, from the name, the rocks which loves to keep the oil stick to it. So the best way to deal with it, add something to your water. Add a surfactant. ضيف كمية قليلة جدا من الصابون السائل مع الوتر in order to remove that oil from the rocks. That's the answer. أنا أتمنى أجوبتي. يعني أنا يعني if they hear me, I don't know how many people here hearing me. I am professor.
Yeah.
أنا عندي مؤلف كتب. أنا خبير. ما أمدح نفسي بس أنا خبير فعلا. أنا am consultant, استشاري شركات كبيرة مثل ADNOC, مثل BP, مثل شيل, شركات مثل أوكس موبل يسألوني. فالمعلومات اللي أنطيها معلومات استشارية مو تدريبية. فأتمنى الناس فعلا تطبقها. عندما يقول لي مثلا أنا عندي مشكلة بالووتر فلودينج والأويل ويت، أضيف له بوليمر. ما أتردد، أضيف شوية بوليمر أو أضيف شوية سرفكتنت. أجيب كمية من صابون السائل وأضيفه وإنجكتد to make the business works. And people listen to me. Actually, big companies they listen to me. يعني شركات كبيرة عندما أقول لهم كلمة يعتبرونها قانون بالنسبة لهم، لأنهم قالوا هذا البروفيسور قالها. So I hope in Iraq, especially in Iraq, people listen, but I don't know. I cannot comment on that. So any more questions?
Okay, I got one question, but I'm just confused of saying it or not, because the one who asked it just misspelling my name. So, okay. He just asking about your writers, your books, if you could give it or tell us where we could find it.
I am in touch with you through the what they call it.
LinkedIn. Yeah.
إن شاء الله أنا أذكر الكتب والبحوث أذكرهن أنا لحضرتك إن شاء الله. يعني ما عندي وقت وما يحضرني كل شيء إن شاء الله. Okay.
Yeah, it's so fine. I'm really sorry. We take a lot from your time. Thanks for joining us today. Thank you for this outstanding. It was out of the world.
Almost 2 hours, yeah.
Glad and enjoyed your lecture. We so appreciate your time and effort and having all this patience to answer all of our questions. I'm really sorry for those who couldn't answer their questions or saying them. I'm really, really sorry. Thanks for joining us today for the lecture, for today's lecture, sorry. Thanks for your time, and we're gonna see you in another lecture. Okay, so I don't have anything today. Thanks. Have a nice night ahead.
Did somebody recording this lecture? Did you record it or?
Yep, it's recorded. Okay. Till now. Yep.
Okay.
It's gonna be. If you want, I could send you the link of it.
Later on LinkedIn if you wish. Yeah. So
yeah. Okay.
Maybe I keep it for some other people. Maybe ask me, I can send them to them.
So, it's okay.
Yeah. Thank you very much for the SPE chapter of Misan University, and thank you for Misan as well. Thank you for you personally, Yamama, because you started the idea.
No,
and
it's okay. It's my
also
pleasure.
for your colleagues
Thanks
who
for
support
accepting
you.
our
And
invite.
inshallah, we do more
Yeah.
in the coming weeks, I can say.
Yeah. Someone asked me if you could give us another lecture later on based on your schedule.
Inshallah. The other one which I prefer to cover maybe gas injection or gas lift.
Yeah. We will be so glad to have that. Yeah. I would finally to re-thank Dr. Sadiq to give us his Zoom to hold this lecture today. He's a doctor from Electricity Department, University of Misan. Thanks too much. And for everyone from SPE team, thank you for organizing this lecture today. And thanks for joining us and holding the lecture and staying with us today for this time. Thank you all. We're looking forward to have another lecture again. You have a nice night ahead. Thanks for joining us again. Good night, everyone.
Inshallah.